This is a presentation of SBE 15, New York City.
Thank you so much for having me here today. My name is Houston Maxwell. I'm the head of Access Services Platform Development for Red Bee Media. As mentioned, I'm not in the United States. I'm in Scotland right now, where it is past 11, past my bedtime, but I'm going to do my best to power through. Now it's animated.
Oh, the animation worked that time.
So today I'm going to be talking to you about automatic real-time captioning. I'll give you a little bit of history of captioning, a little bit about the history of the technology that's driving its automation, which is speech recognition. And then I'll talk about the solution that we in Red Bee Media have in that space. So first of all, a little bit about Red Bee Media. For those of you who don't know us, we're a global broadcast media services and technology company. We're wholly owned by Ericsson, the Swedish kind of huge technology group. And we deliver a wide range of media services, such as managed playout, OTT platforms, media management. And in my part, we do what we call access services, which are things like captioning, audio description, sign language, etc. So in the access services bit, we, like the rest of the company, have a global presence. We've got hundreds of captioning experts with teams in Georgia and the States, but also teams in the UK, France, the Netherlands, Spain, Australia, etc. Just to call out a few kind of key points there, we've got over 20 years of delivering quality captions to some of the most demanding broadcasters in the world. And we do over 100,000 hours of live captioning every year. And we've got a sort of scale within that that allows us to do quite a lot of investment in technology and innovation. We see ourselves as ASR experts. We were actually, ASR being automatic speech recognition, we were the first company in the world, as far as I'm aware, to use speech recognition to drive captioning. So now I'm going to talk a little bit about captioning. To be really obvious about it, captioning is a way of making media accessible to those who can't use the audio from that content. So that's primarily the deaf and the hard of hearing, but it could also be people in an airport departure lounge where the sound's turned down, or people for whom English isn't a first language. For broadcasters, providing captioning has often been seen as a bit of a headache. You know, in major broadcast markets, the requirement to caption is driven above all by regulation, and it's seen as something that's outside the core value proposition a lot of the time. But I think it's important to remember that there's a very significant audience out there that captioning allows you to reach. It's estimated that 1 in 6 of us will have some form of hearing loss in our lifetime. And for people of advanced years, you know, who can be such a core audience, captioning really is crucial in order to making your content properly available to them. And then at the other end of the spectrum, you've got a whole generation of people who look at content on their phones, on public transport and the like. And, you know, they generally do that with the captions turned on. So even though I would argue there's an undeniable value to captions, it's equally undeniable that it's been something that's been very costly to produce traditionally. For one live broadcast, you generally need at least one captioner, and often more. Often it's actually 2 or 3. And obviously that drives in a lot of cost. And that's where automation is starting to come in. So how is live captioning produced? This is a little bit of history. The device you see here is a stenograph machine, a stenography machine. And I don't know if you can see it, but this particular model was patented in 1870. So this technology has been around for a long time. And the key breakthrough from a captioning point of view was the addition of computers that allowed you to turn stenography shorthand into human readable text in real time. This started to be used in the 80s to provide captioning. The first live caption broadcast was the 1982 Academy Awards on ABC, and news programming followed soon after that. The core technical chain of providing live captions hasn't changed a lot since then. You've got your source signal, which has the audio that you need to transcribe. You've got some method of generating that text. You've got software which takes that text and turns it into captions. You've got your caption encoder, which takes a caption stream and puts it into your transmission chain. And then you've got the final presentation, the end user's device, which decodes that and presents it on screen. Stenography was and is a great tool for that text generation, but it takes a really long time to train people, and it began to be used less and less for court reporting, and so it was harder and harder to train stenographers. Back when we were part of the BBC in the 1990s, we pioneered a new technique, which has gone on to be the most common method of producing text for live captions. It's called voice writing in the States, or we call it respeaking in Europe. And it makes use of speaker-dependent voice recognition software, such as Dragon Naturally Speaking, or back in the day, we used Via Voice. And basically, a trained captioner is watching the media, repeating everything they hear in a clear, level voice, spacing out between the words, speaking any punctuation. So they'll say comma, they'll say period, and also speaking any speaker changes. The model they used for that has to be trained specifically to their voice to get the right accuracy. So if you ran the audio track of any content directly against these ASR tools without a captioner, you'd get garbage. You'd get something that was totally unintelligible. But with the respeaker there to mediate it and repeat it clearly, you could get to really high levels of quality. But you were still dependent on the captioner, and that obviously means you've got a relatively high cost. So the possibility of lower cost models for live captioning were always going to depend on advances in that speech recognition technology, and they were a long time coming. So what is automatic speech recognition? It's a machine learning use case, and it's actually one of the areas where machine learning had some of its earliest successes. As I've mentioned, we were using speaker-dependent speech recognition and captioning for about 3 decades, which is long before AI and deep learning and all that were the buzzwords you hear now. Basically, the task of a speech engine is to decode a sequence of noise, that is speech, to turn that into a sequence of phonemes, and then to try and guess, based on a language model, what is the most likely sequence of words that these sounds might represent. And one of the things that means is the more likely and common the phrase is, the more likely it's going to be recognized correctly. So if you have these two identical phrases phonetically, he shaved his hair and he shaved his hair, a speech engine is basically always going to hear the first one because that is the one that is probable. But of course, that can be a challenge if you're captioning a documentary on someone with a pet hair. Context is absolutely key for speech recognition to work well. And the early models and the ones we were using in respeaking back in the day, those were based on trigrams, which are groups of 3 words. And so it was the probability of any 3 words occurring in sequence. You'd kind of have the last 2 words and guess what the next one is going to be, or what the most likely one for the next one is. Those 3 word sequences would never have been able to interpret any differences there, but the models have come a long way since then, and they can now meaningfully take context clues from not just many words or sentences away, but sometimes paragraphs away. So where have these improvements got us? This table shows the progress against what's called the switchboard dataset over the last 20 or so years. The switchboard dataset is something that's used in speech recognition research to benchmark models. It's a dataset that consists of short clips of telephone calls. And it's probably worth pointing out that most broadcast material is a lot trickier than this dataset. So at the first data point here, 95, we were already able to do respeaking, and with respeaking you could get under 10% errors. But if you ran this particular data straight against the audio, you'd get up to almost 45% of the words wrong. However, things did eventually improve, and especially when deep learning came along and those techniques involved, and that saw really the things start to get really quite good. In fact, on this particular data set now, speech recognition engines are comparable to an average human transcriber. But as I said, broadcast content is especially tricky. There's a lot of very specific topics covered. I mean, you can imagine trying to cover something like this. There's lots of very specific vocabulary. Everything tends to have a particular topic compared to everyday speech. There's a lot of background noise and music in television. People speak over each other and so forth. So when facing up to that broadcast content challenge, not all speech engines are created equal. And for that reason, at RedBee, we do constant systematic evaluation of the best engines out there to see which ones are best and for what content. And we also work very closely with the speech engine providers to help them improve for our types of content in the media world. It's worth noting that when we started evaluating speech engines, we assumed, in part because of our background in training models for re-speakers, that the best recognition was going to come from training custom models. But that hasn't really been the case. The best performance you get comes from generic models, which are just trained on immense amounts of data. You can get some improvements from further tailoring those towards some up-to-the-minute vocabulary, but fundamentally it's these massive generic models that perform the best. It's also worth saying that even the best speech engines do have their weaknesses as well. No speech engines deal well with overlapping speech, and people on TV do like to talk over each other. And they really struggle also with speaker segmentation, which instinctively feels like something that it should be an easy problem for a machine learning algorithm to tell when one person is speaking or another person, but there's really been quite slow progress there across the board, although we do have some hints that improvements are imminent. So now I'll talk a bit about ARC. ARC is Red Bee Media's automatic real-time captioning solution. It takes our captioning expertise, our captioning platform developed over the last decade, and the most accurate speech recognition available to deliver the best automatic captioning on the market today, in our opinion. At its simplest, it's basically a case of you give us your signal and we return you your captions. It's a cloud-based service hosted in AWS. Once we're set up with you, we take a low latency feed of your content. We process that through the ASR. We send that through our ARC system to do the formatting and coding as captions, and then we send those captions to your encoder. The overall latency of this process is similar to what you'd see with a skilled human captioner. The other important thing we need to know is when you want the service on and off. For activation and deactivation, we have a few options. There's an API, so you can trigger that using your playout automation system or any other automation service in your ecosystem. Or there's a control page you can log on to trigger it on and off as required. Any captions that are generated using our ARC system are also stored in a database for any compliance or reuse requirements that might come along. So we've talked about how speech recognition works and how live captioning works at a basic technical level, but how do we take those technologies and bring them together to produce the best possible quality captions? Well, there's three layers to that. There's the ASR engine. So as mentioned, we do constant evaluation, and that allows us to make sure we're using the best engine for the job and have it configured in the best possible way. An example of that configuration is managing the trade-off between latency and accuracy. You can always get a little bit more accuracy by letting the engine think a little bit longer, but latency is really important for the end user of captions. So it's a case of trying to find the right sweet spot there. Then there's our layer of expert curation. This is where our highly skilled and experienced captioners train in the vocabulary that's going to give your content the best results. And it's very much not a case of throwing all relevant vocabulary at it. If you give it a huge list of vocabulary, often what you'll find is you get a lot of false positives and accuracy is actually worse. So our captioners will select the vocabulary that's likely to give you the best results, and we see that can give a 25% reduction in incorrect words versus out-of-the-box ASR. And finally, our ARC platform has a whole formatting layer that comes from all of the work we've done over captioning over the last decade. It allows you to make sure that numbers are correctly formatted, that branding is being adhered to, that density is controlled, and things like that. So to give you a few concrete examples of the types of errors we can correct. So in the first line, you've got words that either aren't in the dictionary or are so uncommon that they're rarely recognized by the engine because it's all about probability. So we can help it get President Bolsonaro instead of President Boson. Then the second example, this is $37.80. I mean, that is correct. That is what was said, but it's very difficult to read. And it takes up a lot of characters. And the more characters you have to put on screen, the more you push up latency with captioning. So we have an extremely complex set of rules. I mean, you would not believe how hard numbers are because every different type of number, a date, a weight, a phone number, they're all presented in a different way. So we have literally tens of thousands of rules that look at the context around a number And also the ASR can produce it in lots of different ways and turn it into something that's readable. So you get that nice presentation of 37 books ID. In the third example, we've looked at a lot of ways in which repetitions can occur and things that are commonly stumbled over or things that are said that are redundant. And we remove those so that you get all of the content, but you kind of keep that density down as much as possible, which again contributes a lot to readability. It's worth saying human captioners will generally remove some redundant content to make the captions more readable, and automatic speech recognition itself can't do that. It will transcribe every single word it hears, which when the content is particularly dense can be challenging to read. And finally, we can enforce branding. So a speech engine might come out with SBE 15 all spaced out like that, and we can know that it's going to come out like that and either enforce a rule by an auto replacement or just feed in the vocabulary. And often one thing is more likely to help than another. So our captioners will choose the one that's likely to give the best results. Okay, I will show you now a demo clip. For the purposes of this presentation and in honor of the imminent Olympics and Paralympics, which hopefully will go ahead, there's a clip we made about some services, some additional access services we provided for one of our clients during the last Paralympics. Now, although this clip isn't a live one, the captions running on it are running in real time as if it was a real-time broadcast. So it's the sort of performance you'd expect to see in your content. And I think you'll see it is really great results. I mean, like any live captions, it's not perfect, but it's absolutely comparable to the sort of accuracy you'll see with human captioners. Now, video streaming never works that well on top of a Zoom call, but hopefully it's watchable and hopefully I remembered to tick the audio thing. Wave your arms at me if I didn't.
You asked me, what it's like, what it feels like when you're faced with that sort of challenge, and it's exciting. It's kind of why you get up in the morning for the job.
Paralympics 2016 Rio.
Channel 4 came to us with a particular challenge, which was to make the Paralympics the first totally accessible Paralympics that they'd ever done.
We wanted to do live signing, we wanted to do live audio description and live subtitles. We wanted to go in areas that other broadcasters can't go, and they said yes.
Is that a big deal?
It's a huge deal. We hadn't done that before.
It meant getting in new technology. In this case, we were putting in some new technology from the States, and it also meant people learning new skills.
As all of the Paralympic athletes were finalising their training and striving for glory, we were training but in a very different way.
Because it was the year of the disabled, Channel 4 said, actually, we want a deaf translator. We don't want to have a hearing interpreter. The number one thing in my mind was preparation.
We had done a lot of research and prep over the summer. We'd done rehearsals.
What it means when you're doing it live, of course, is that there's no going back. There's no re-recording it. You have to get everything right first time.
I was in the Channel 4 building, crossing my fingers.
And when it came to the hour, as all the athletes are limbering up, waiting for that starting gun, over 5,000 miles away.
The stadium's absolutely packed.
Ready to press the on-air button and go live. And when I say live, I mean live.
So there you go. Hopefully you can see that the quality you get there is the sort of quality you're going to see in any sort of live captioning scenario. So to sum up, I think ASR and automatic captioning are revolutionizing the production of live captioning. And for broadcasters who are doing captioning, your captioning costs could be significantly reduced using these tools. But also we're seeing that content that previously it was just not feasible in its budget to caption it can now be made accessible, which allows broadcasters and platforms to extend their reach. But I do think it's important to embrace this technology in a responsible way, to use it in the right way, on the right content, the right audience, and giving your audience the best quality available at the budget you have is crucial. So, that they continue to enjoy your content, and otherwise you could end up alienating some of your audience. So yeah, we believe as a company with 20 years of captioning experience at our core, we can help broadcasters do that. And we think broadcasters in the right areas can save a lot of money now. Thank you for listening.
Fantastic. Thank you. Going to open it up for questions for Houston.
Well, first thing is, Houston, would you pass along your contact information?
Absolutely. Pleasure. How should I do that?
Well, what's the best way if we're gonna contact Red Bee? What's the best way of doing that?
Probably the best thing to do is drop me an email and I'll send you on to whoever I need to send you on to, or talk to you myself, depending on what you're looking for.
And your email is?
Should I put it in the chat?
Yeah, put it in the chat. That's the best thing to do. Yep.
As a user of Red Bee, I have to say that WLVT, we've been very happy. There were some initial bumps in the road, but they were really responsive and got everything sorted out pretty quickly, and it's been really reliable.
Thanks, Andrea, and thanks for setting this up for us.
Houston, it was a terrific presentation. I'm kind of new to a lot of this, and you really made that interesting. And I have a question on latency, because I for some reason use a lot of the closed captioning. I don't know if there's too much noise in my house or whatever, but it seems like I have it on lots of different places. How good can latency get, or how good is it time-wise, or is that how can you measure that, or give me an example of where it's going?
So what you tend to see with live captions produced in real time is around 4 to 8 seconds.
Okay.
There's a lot of factors that can feed into that, and there are things we do. We generally are looking to get kind of pre-transmission, low latency audio streams, because that helps. There's actually some things you can do in the encoders as well. If you've got a kind of encoding delay, you can maybe insert the captions afterwards. We do that with some customers, although that's quite technically complex to implement, but you can buy back a lot of time that way.
So 4 to 8 seconds is very good?
That's typical, yeah.
Typical, okay, because then I must have seen some that are even much less than that. I don't know where, but some of it, it's, the show's over or something, and it's still, it seems like it's more than that. Will that, and then I'm not clear, is the best and most accurate captioning then actually, there is a human involved in this?
Yeah.
Always?
The best captioning you can get is where there's a script for live. Okay. And then you can have a human literally cue out the script, and that, you've got a pretty close to 100% accuracy, and you lose that latency factor. Okay. But on top of that, where it's something where there's no script, the most accurate captioning you're going to get is, a very skilled human captioner for sure.
Okay.
And especially on more like the automatic captioning is really good now on news content, for example. In general, it handles news content really well, and you're not going to notice much of a difference. But on something like sports, automatic captioning struggles a lot more. The way people speak in commentating sports, it's a lot more challenging for speech recognition. So it'll take a little longer there, whereas a person can process all of that. And
well, thank you. Great presentation.
How does it deal with multiple people speaking?
Speaking one after the other, or speaking on top
over each other?
Different characters.
Speaking over each other, you tend to get random words coming out. You might get one word from one and one word from the other.
Does it identify the speaker?
No. The speaker ID is, as I mentioned, it's one of the things that is less good at this stage. It's sort of not good enough that we don't recommend turning it on. We think it creates more confusion than it resolves. But speaking with our kind of speech providers, we do think there's probably improvements there coming fairly soon. What it would do when people are speaking over each other in that scenario, I still don't know. That is very hard for speech recognition.
Yeah.
And then you talked earlier about the AI component, where it picks up context. How can you talk a little more about that?
Yeah, so speech recognition is an AI algorithm. That's how it works. And the initial models were, I mean, all AI is just probability machines. You know, that's how AI works. It's give it an input, and based on a bunch of other inputs and based on some training, what's the probability of this outcome? And in this case, it's chains of words or the probabilities it's trying to figure out. So given all of these words that have just happened and this sound, what's this next word most likely to be? But it's always been something that AI has been particularly good at. Language, although language is so complex, it does seem to suit these sort of models, and it's kind of scary. I don't know, there's a massive machine learning model they've trained now that can generate text. I don't know if you see some of the output of this on the internet, and it's scary, the stuff it can generate of its own accord. You know, the AI has no real true understanding of anything, but just purely on context and probability, it can create this weirdly convincing language production.
Got it.
Very good.
Okay. Any other questions for Houston? Well, Houston, thank you very much for joining us late your time, and for the great presentation. We do appreciate you joining SBE 15, and as Jeff said, this will be edited and posted to our website, and there'll be additional views there. So hopefully the rest of our chapter who couldn't make it live will get a chance to see it on demand.
Thank you so much for the invite.
Thanks for joining us. Please remember to subscribe to SBE 15 New York City.